Oscillations. In this chapter, we discuss about damped oscillations and undamped oscillations. Before we start, you should remember what is an oscillatory motion. See, you imagine a simple pendulum of length L, which is at the mean position O. And the medium is air, it is surrounded with the air. And I took the pendulum bob to a certain height, say point A. And you know that from O to A is the maximum displacement, and that is called what? Amplitude. So from this position, what I did now, I just release. So when I release, the pendulum bob starts from A, reaches the point O, and then reaches the point B. So from A to O, then O to B, and after that it will come back from B to O and O to A. So the bob is executing to and fro motion about a mean position. So from this example, we will come to know what is an oscillation. So oscillation means it is a to and fro motion. That is, to and fro motion means from the mean position it can move towards right hand side. Again from the mean position it can move towards left hand side. If there is to and fro motion about a mean position, then that type of oscillation is then it is called what? Oscillatory motion. So just now we learned what is amplitude. So amplitude means maximum displacement from mean position to the point A. Imagine that the medium is air, and at the same time the opposing force acting on the pendulum is minimum. There is no opposing force. That means that opposing force is called what? Resistive force. Equals, say, 0, negligible. Means in this situation there is no opposition acting on the pendulum bob. Means nothing is there to oppose. Due to that reason, the pendulum will keep on oscillating with the same amplitude. So we can represent this like pendulum started from here. This is the mean position, the maximum position, reaches the mean position, then the right hand side, then again mean position, right? So this type of oscillation you will be getting. So you can see that this is the maximum displacement. Suppose this is A plus A and downward is what? Minus A. That means suppose this is 5 centimeter, this is also 5 centimeter, 5 centimeter in the upward direction. This is 5 centimeter, 5 centimeter, 5 centimeter in the downward direction. Then conclusion is, in this type of oscillation, amplitude of oscillation remains same. Here amplitude of oscillation remains same. The reason is there is no opposing force. Then this type of oscillations are called undamped oscillations. It is called what? Undamped oscillations. So very simple. Undamped oscillations are the oscillations acting on a body when there is no resistive force, when there is no opposing force. If there is no opposing force, we know that the pendulum bob continues to oscillate with the same amplitude. Then it is called what? Undamped oscillation. But only this is theoretically is possible, because we know that even though air is there, air opposes the movement of the pendulum. Due to that reason, because of the opposition, we know that after some times what will happen to the amplitude. Earlier it was a 5 centimeter. From here 5 centimeter, then 5 centimeter. But during the second oscillation, 5 centimeter reduces to what? Say 4 centimeter, 3 centimeter, 2 centimeter, and finally it becomes 0. That means the oscillation dies out. We say that the oscillation dies out, and it is due to what? Resistive forces acting on the pendulum. Then this type of oscillation is called what? Undamped oscillation. So conclusion. A body is said to be in undamped oscillation if there is no resistive force, if there is no opposing force can be in the form of air or in the form of any liquid. A liquid can oppose this motion, air can also oppose this motion. Then it is called what? Undamped oscillation. Then next one is forced oscillation. Forced oscillation. That means again, I'll take the example of simple pendulum. It is taken A, mean position O, then to the point B. We know that maximum amplitude equals a 5 centimeter is the amplitude. This is also 5 centimeter. Okay. So same thing. What I did, I released the pendulum bob from A. It goes to the point O, then point B. Again, we'll come back from B to O, then O to A. The reason is the opposing force we neglected. Since we neglect the opposing force, what type of oscillation it will be having? It will having same amplitude. Suppose this is 5 centimeter up, downward also 5 centimeter. We say that it is undamped. But just now I told you that it is theoretically possible, but in reality, you know that this pendulum is subjected to some resistive force. Because of the resistive force, what will happen when I release the bow from point A to O, then B to O, then B to O, then O to A. So this continues, but at the same time, because of the resistive force, what will happen to the amplitude? Amplitude goes on decreasing. But I wanted to maintain the same type of oscillation. This oscillation should continue. But we know that because of the external force acting on this pendulum, sure, the oscillation dies out like this. This is the waveform. In the beginning 5, then 4, 3, 2, and finally comes out. It dies out, the amplitude of oscillation becomes 0. But I wanted to maintain the same type. In that case, what I have to do to maintain the same type of oscillation, I have to use an external periodic force. See, this is a tuning fork. This is the external periodic force. Now look here. In the beginning, there was no external periodic force. Due to that reason, what happened? The pendulum oscillates and finally amplitude becomes 0. It comes to rest. But I want to maintain the same time oscillation. The oscillation should continue. Means to continue the oscillation, I have to provide some external periodic force. Example in the case of a tuning fork. So what I have to do? During this oscillation, when the pendulum oscillates, what I did, I keep a vibrating tuning fork near to this one. So this vibrating tuning fork has certain frequency. So because of the presence of the vibrating tuning fork, the pendulum continues to oscillate with the same amplitude. Then those type of oscillations are called what? Forced oscillation. So in the case of forced oscillation, to maintain the same amplitude, some external periodic force is required. In this example, I use a vibrating tuning fork. And because of the presence of vibrating tuning fork, the pendulum continues to oscillate with the same amplitude. Then that type of oscillation is called what? Forced oscillation.